we come to the next example. So consider a weighted complete graph G on the vertex set v1, v2 up till vn such that the weight of the edge vi, vj is 2 times absolute value of I minus j. And then it asks the weight of a minimum spanning tree of G is, and then we are given these 4 options and out of them one is correct. So what are the main points in this graph? Okay, so the graph is complete. Complete means every vertex will be connected to every other vertex. That's complete graph. And then there are some weights given to the graph, and the weight is given by this formula. So suppose there is an edge vi vj, so the weight is 2 times of I minus j. So what does this mean? Suppose you have an edge, let's say you have an edge, sorry about that, it's just my, this thing is too thick. Okay, so suppose you have an edge between, let's say v1 and v7. Okay, we are talking about the edge between v1 and v7. Every vertex will be connected to every other vertex. Okay, so there will be an edge between any two pair of vertices in this graph. So suppose we are talking about this edge, so what will be the weight of this edge? It will be 2 times I minus j. So 2 times mod of I minus j, or absolute value of I minus j. And what is I in this case? 1. And what is j in this case? 7. So I minus j, that is 1 minus 7, is 6, and 2 times 6 is 12. Okay, 2 times 6 is 12. So the weight of this edge will be 12. So that's the main point in this, that how you give the weights. And then it is talking about any normal, any general pair of edges, pair of vertices. It's saying that you take any vertex vi like this, and you connect it with any other vertex vj like this. So, and then it tells you about the weight in this case will be 2 times I minus j, this absolute value of I minus j. So that is the main point. And then what is it is asking that what will be the weight of the minimum spanning tree in this case. Okay, so what is a minimum spanning tree? A minimum spanning tree is a tree that includes every vertex in the graph. Okay, and there is a condition that the total weights of those edges should be minimum, and there are algorithms to find minimum spanning trees. There is Prince algorithms, there is Kruskal's algorithm. Okay, so we'll use the idea of one of those algorithms to find the weight of the minimum edge in this case. So what I'm going to do right now is I'm just giving sort of these labels to these vertices. Okay, so suppose we have v1, v2, v3, and we go so on up till, let us say we go up till vn. Okay, and then it's a complete graph, so every vertex will be connected to every other vertex. I'm not drawing those edges for simplicity. What I'm going to do is just draw the minimum spanning tree. So you think that every vertex is connected to every other vertex, and from that complete graph we will find the minimum spanning tree. So the idea of algorithm, the minimum spanning tree I'm going to use is from Kruskal's algorithm. Okay, it's from Kruskal's algorithm. So in that algorithm, what you do, you choose n minus 1 edges. If there are n vertices in the graph, any tree will have n minus 1 edges. So you pick n minus 1 edges. And how do you pick them? Like, what condition do you follow? When you pick these edges, you have to start with the least weight, okay, and you keep going on and you keep picking these edges, provided that you don't form a cycle, because a tree cannot have a cycle. So the second condition is that there shouldn't be any cycles. And the third condition is that basically these are the two conditions. You stop when you have picked these n minus 1 edges. And yeah, the main point is that you start with least weight. You pick the edge with the least weight, and you keep on repeating this thing. When you have picked the edge with the least weight, and then from the remaining graph you see which edge is of the least weight, and so on. All right. So we're going to implement this algorithm in this, and sort of implement, see how we can get the minimum spanning tree. So you know that the weight of the edge is 2 times I minus j. Okay, so suppose I start at v1. So what I can do is, there is definitely an edge between these two. So what will be the weight of that edge? It will be 2 times 1 minus 2 absolute value, which is 2 times 1, that is 2. Okay, and similarly there will be an edge between v2 and v3. What will be the weight? 2 times of 2 minus 3 mod, absolute value of 2 minus 3. So this will be again 2. And this way you can go on up till vn. And when you will reach vn from, let's say, vn minus 1, alright, so you are at vn minus 1, and you include this edge in your spanning tree. What will be the weight of this edge? 2 times of n minus 1, which is again 2. So all these edges that you pick will have weights of 2, and when you will reach out here at this edge, you would have completed your condition of n minus 1 edges. So that's the time to stop. You have picked your n minus 1 edges, and all those edges have a weight of 2. So if you want to write the weight of a minimum spanning tree, that will be nothing but you add all these weights, 2 plus 2 up till this. So that is nothing but 2 plus 2 up till the last 2, and these are n minus 1 2's. Okay, so basically you are doing 2 times n minus 1, which gives you 2n minus 2, and that is your answer. Okay, so your option B is the correct option, and this is the total weight of the minimum spanning tree. Okay, so in this case you don't have to draw the complete graph and then choose. You can think that the graph is there, and then you can think like, how can you pick these minimum weight edges one by one so that you don't form a cycle. Okay, because that you don't have to form cycles also. But if you keep on going like this, then you're done. All right.